and I used to work for a company in Elston Wicks named OpenSimSim, but now um, I will move to Canada very soon. So yeah, this is probably the last talk I will give in the Melbourne Golang meetup. So yeah, so I'm very happy to share my some of the random philosophies I collect when I learn in Go. I start to learn in Go like maybe like 5 or 6 years ago, and when it's still like 1.2 or 1.3, and now I think it's on the way to 2.0, and it has a lot of features, and together with the generative, it will make Go become a very simple yet a powerful language to make a robust backend or a service microservice. Yeah, so to share about my my observation. So yeah, sorry. My first impression is Go is very simple, and its simplicity is the ultimate sophistication, which helps developers to achieve many things. The good, the good thing about simplicity is there only one way to do like certain things. For example, if you want to create a slice, or you want to filter the result, there's only one way to use, like for example for range, and there's no like fancy the standard library only offer like around 20 keywords. So I think that is a powerful way to force users, force and developers, the different developers in the team have to use like the same method or the same style. That's the reason that we everybody's maybe doesn't know to, doesn't want to use Go FMC or Go Font at the beginning, but everybody loves it. So that is the how the Golang go to. Being all the developers together and working towards the same goal. Okay. So my second observation, if in Golang, if I want to, yeah. So the things we usually we already heard about, like for example memory leak. We want to try to avoid in our program. Yeah. So you can like, use like, some certain tools like pprof, or like you want to like debugging it, or like let's see. Like for example, we want to see the allocation of the heap and memory. And from my experience, actually most of the issues it comes from when we want to establish like some network connection, or like initialize some IO operations. So a general rule of thumb is we open something, then you like we should close it. Oh, sorry, I think I should close it yeah, immediately. So or like close it in a defer statement. So like make sure that we never forget it. So the use case, if we have a context with timeout, then we should call the cancel function. If we read a file or read we request a HTTP request, then we should close it. Or when you use a lock, so for example, if you want to use a lock, then we have to unlock it. When we want to query a rows from the database connection, we have to remember to close the rows. And similarly for the Redis, when we want to start a service application, we can use like very simple ways of using channel. Like we listen to the interrupt signal from the terminal, or when the service restart. So we can see that like if we want to make the application running clean smoothly, when for example we run it in a Kubernetes or like run it on the cloud, And when we in deployment, we have to like turn off or like restart a service. So that we we send a signal to our server, and if we trigger the shutdown function. So all the logic we want to like gracefully shut down the server, you can put in the shutdown function. And if we have to close everything in the server after we restart or shut down. So yeah, we can see like in this example, we have a context for time 10 seconds. But actually, I have to call the cancel. Yeah, because it's like the open. We want to open something, then we have to cancel or close it. So yeah, move on to the next. I think this is very popular thought. Actually, one of the goal proverbs is when for most of the functions, we should accept interfaces, and when we should return struct. So the need is in the eye of the beholder. So if for each function we have different requirements, and we have input and output. So the input is something we cannot control. So that's the reason that we want to use interface to define a set of functionalities. And when we get the result, then it should be like some struct. So like it has a determined attributes, and we can test it. And for interface, we can mock it. So it's the access interfaces and return struct. We have to test easier. The bigger is the interface, the weaker the abstraction. So if we have the big interface, can do a lot of things, then it's hard to abstract it. So here I have an example. So here I have yeah, it's actually like coming from production code. I have 2 layers. One is in the control layer, and another second layer is in the command. And in the controller, I have yeah, I get the database connection. And in this case, I get it from replica because in this API, I want to get a notification, and this actually is from a very big table, and I want to connect to replica. This function in controller we call a get notification to retrieve from a database. It's in the command package. So there's some new requirement, and I have to every time when the API call get notification, I have to mark. If you notice, like in, for example, some in some website, if you click on the notification, then actually like there's a red icon there, and if you click it, then immediately you have to mark. You have to make the red icon disappear. So this, in this requirement, we want to like after user call to get notification, then we want to update the new have new notification flag to force in the in the same database, but it's actually in another table. So we have a flag table, and we want to set it as a false. So we don't we just like run write the code, and we just pass the a normal database like using like the SQL. This one is from database SQL standard library. Then actually we just call the update the flags. Actually, we didn't know that like from the controller layer, it's getting from the replica. Yeah, it's, as you know, like if you a lot of like database replica, actually you cannot update the flag. So this we cause the bug. So if you think like and in fact this kind of bug is very hard to detect in staging or playground environment, because usually in staging environment, you always point. I mean, we have we usually like config that replica and main database is pointing to the same database host. So that means the only things this bug we only occur on production. So it's very annoying. I mean, we usually we can do it. I mean, we can use the accept interfaces, return struct principle to, I mean, to force the input of the function, which only define a limited functions or a limited behavior for the package. So here I have I mean, this a more like proposed a better version. I have a storage packet. This have a list of behavior for replica database pool connection, and it can, I mean, do only the query. So query the row and the query context. I have another the interface, which actually include the query interface and also like do all the update in the execute context. So it's very like a simple interface and definition. Yeah, we can see that like, I mean, the interface segregation principle here, like the SQL comment, we actually if you extend all the functionalities of the SQL replica. In our code, we can, if we want to use a V1, I mean, you can see that like, if you want to just like access, I mean, the replica only, yeah, then we can use, I mean, we define as a storage.sql replica. But if you want to get notification, you want to pass yeah, you want to update it. Actually, we have to use a storage command. And yeah, this V1 here is actually it should be the fix for, I mean, for the bug. And also like we need to update in the controller, I mean, to get the data controller from sorry, so the database connection from the main database. So yeah, so the yeah, it's easier. That's the one example I want to illustrate. I mean, to use, we should use like a interface to define the input. So it's yeah easier for, and actually we can narrow. I mean, all those like we only want. I mean, this functions only do like certain things. Oh, okay. So next is clear is better than clever. So you usually like as we see a lot of things like in Golang. For example, we don't have I think it's called, I think it's unary unary expressions, like we want to write in single one line. I mean, in Golang we cannot do that. So what we have to do, like usually if we want to check, usually you have to write if else statement. So actually like we split into multi lines. I guess, I mean, what Golang, the core principle is we want to make it clear. So actually we want to modify something, we can just, I mean, we can narrow down to exactly, I mean, one object. Yeah, in this example, we have like, for example, a function to get the location. It's actually return the latitude and longitude, and I mean, an error. I mean, the purpose to make it clear is actually we should name, I mean, the return response to something more useful. And we can add some more comments. So actually, I mean, the focus on clarity, and I mean, add documentation, which makes the collaboration, I mean, easier for like, and actually make, I mean, the code easier to understood. Yeah, and move on to the another principle. Yeah, there should be no else. So my intention always like in writing code is to reduce the number of else statement, because the else statement is sometimes if you have too many if else, it might make, it increase the complexity. And actually we can use like some Go cycle to to measure the cyclomatic complexity of the Go function. So the rule of thumb is if you can return, you have an if, then you think that it's actually a good to return the result. Then yeah, and in the case we have too many else, then we can use either we can refactor it to a new function, or can use switch. Yeah, so yeah, that also come to my new my more opinionated philosophy. When there are two cases, then we should use if. But when there are like more than three, or more than or equal than three, then we use switch. So for example, if you we just check the status equal to create, then I think it's very straightforward. But if you have more than three possible value of the status, like create, delivered, or something else, then switch is we come to rescue. There also like we can, even the logic is complicated, we can use like multi-switch. Now is the code with if go from the order, check the order status first, take the order amount, and then other things. So yeah, so is my observation. Here comes the last one. Usually we want to we do a lot of copy on slides. So we use append, and the normal way is like, for example, here we have a result, and we want to copy the schedule ID to the schedules array. So this I think it's very straightforward. But in the case we know the size of the slides in advance, so we can allocate it to have the correct size. Using Mac, we can look through the result and assign to the location. So why we need why this one is better, because if you allocate the size at the beginning, then after that we only like copy the values to the correct location on the slide. Otherwise, if we do the normal way append, on this append, we is as we know, each slide we have like we have a three property. One is length, which is the current length of the slide. Second is the capacity, it is like the maximum it can make, and the third one is the type of the slide. So if every time we do append, and if it reaches the the default capacity, then it actually copy the slide to a new slide. It try to create a new slide with a double size, it copy all the values into. So this is something like doing in it was done internally in the append function, which actually we don't really have a visibility here. So here I give an example of why this way we help us to do some in a more complex use case. So here I have a schedule, which actually like I want to get a list of schedule struct. It's actually copy. That's some like expensive converting. From the result. So I thinking, oh yeah, so why not I put it in the Go routine, make all the process. I have get my schedule here. which is like a very expensive operation. And if we return the result on when I append it to the schedule array. But I mean, if you, but okay, so now it's like my question. Do you see any problem with this code? Anybody want to share?
No one's saying anything.
Okay, thank you. Yeah, it's actually it has a very tricky bug in this code. So
actually, was Sam about to say something then? Was that Sam?
Yeah, I'll shoot. Yeah, it looks like you've got this schedule slice, which when we append to it, it's being done in separate Go routines each time, and so they might step on each other's toes.
Yeah.
Is that the bug that you were thinking of, or am I thinking of a different one?
Yes, I think you got it the right direction. So yeah, thank you, Sam. So I think it's in the normal, I mean, a typical Go routine. If you want to update, I mean, the shares memories. So usually we you have to know to make sure that, I mean, when the two Go routines, I mean, it's try to update the same memory location, it shouldn't, I mean, cause any race collision. So there's a possible race collision here. Since like we use append and remember, like, if you're on the append function, when the slice reach to the near, I think around like 75% of the capacity, it actually allocates the new, I mean, it copy to a new slice with the double size. So I mean, in the case like if we have the two Go routine and it's trying to update to yeah, it's when you try to append and the size of the slice is already reached 75% of the capacity, then I mean on each Go routine we actually create choose a separate copy, and when you append it, then actually it's sometimes or if we go, I mean, if we encounter invalid memory because the two Go routine we create choose separate new slice and the size to the original schedules. So yeah, I think one of the fix is we just maybe we just add a lock in like before we in the before append and after append, then we unlock it. Yeah, and another the second fix I think it might be better without the lock is we can use the pre-allocation of the schedule array and the slice of the schedule. We have exactly, I mean, the length of the result. In this function, we pass the location we want to update on the schedule slice. So to get my schedule, we only affect only one, I mean, location exactly, I mean, the different location. So I mean, all those Go routines, they would never update at the same location on the index. They never update on the same index on the slide. So I mean, we can solve the race collision by using the this trick. So yeah, so that's all my I can share today, and yeah, hope you guys enjoy. Thank you.
Thank you.
Thanks, Dan.